Now let's go through a few more derivative rules. Let's review. So the derivative of sine is cosine, and then the derivative of cosine is minus sine. The other ones are a little bit trickier. So what we can do if you just don't remember it is that you could try to use the quotient rule or product rule or whatever rule that you remember to solve it. So for example, if you don't remember what tangent is, so the derivative of tangent, I'm going to tell you so you can actually just memorize it. Secant squared. All right, so just in case you don't know what secant squared is secant x, the whole thing squared. Please do not write it as secant x squared. That's not the same thing. This is saying secant of x and then the whole thing squared. This is saying secant of x squared. That's not the same thing, so please don't write that. All right, so the derivative of tangent is secant squared. Now, if you really don't remember, what you can do is change it into sine over cosine. I don't recommend you doing that because it's going to take you way too long, but just in case you just don't remember what derivative of tangent is. Okay, so this is basically a quotient rule because we have two functions divided by each other. So low d high minus high d low all over low squared. So cosine squared minus, and then those multiply together to get positive sine squared over cosine squared. We know that cosine squared plus sine squared is 1. Sorry, I forgot the square there. So this becomes 1 over cosine squared. 1 over cosine squared is secant squared. So that's how we get secant squared. But again, please just memorize it's secant squared and not do the quotient rule. All right, you can run the exercise for these three as well. So change cosecant into 1 over sine, change secant into 1 over cosine, and then cotangent is cosine over sine, and then do the derivative that way. But I'm just going to tell you what it is, so it's a little bit easier for you. Okay, cosecant is minus cosecant x cotangent x. Derivative of secant x is secant x tangent x. Derivative of cotangent x is minus cosecant squared x. Now you may be thinking there is no way I can remember all that. I think AP does understand that you cannot remember all that. So really on the AP test, you need to just remember these three only. The other ones you probably need it in college if you're going to higher calculus classes, but for now, just these three. All right, so let's go ahead and try these. Find the derivative of the following. So this is pretty easy, just apply the same rule as before. Derivative of x is 1 minus derivative of tangent x is secant squared. So 1 minus secant squared. And if you do want to go one step further, you can remember that 1 plus tangent squared is secant squared. And then if we're trying to figure out where 1 minus secant squared is, we can just subtract secant squared on this side, or on both sides. And then 1 minus secant squared plus tangent squared is 0. And then if we move that tangent square over, then 1 minus secant squared is minus tangent squared. So this is really minus tangent squared. So it's another way to go a little farther to simplify. All right, y equals x secant x. So this is going to be a product rule because we have a function times a function. Remember, function is in terms of x. So the derivative is x derivative of secant, which is secant tangent, plus secant times the derivative of x, which is 1. We're pretty much done here. There's not much we can simplify. We can probably take out the secant x just so that looks a little bit cleaner, but that's pretty much all you can do. All right, let's have you give this one a try. Y equals 1 minus cosine x over sine x. So you can, do it any way you want. You can use the quotient rule. You can change it to another trig function first. It's up to you. But go ahead and solve this problem and come back and check your answer. All right, so here's my answer. So I simplified a lot because I want to make sure that the derivative is as simple as it can look. So here's the answer, 1 over 1 plus cosine x. All right, let's talk about some more notations. So when we talk about first derivative, we just derivative, we put a prime on it. So f prime is another way of saying f of derivative of f. And that one prime just means it's the first derivative. So if we want to find the second derivative, we would write 2 primes like this. So third derivative would mean we put 3 primes on it. Now starting with fourth derivative, we don't actually write it like this because it just gets very messy. So we write it like this, f, and then parentheses 4x. And then so if you want the nth derivative, we would say f, parentheses n, and then x. Okay, let's look at other notations. So another way of writing first derivative we know is also y prime. So same thing here, we would write y double prime. This would be y triple prime. And then we would start getting into the parentheses, and then same thing here. Now in terms of d dx, so dy dx is the derivative. So if we want a second derivative, here's how you write it. D squared y dx squared, like that. Okay, and then third derivative, d and then cube y dx cubed. And then fourth derivative would be d4y over dx4. So then the nth derivative would be dny over dx to the n. And so same thing, if we are trying to take the derivative of a function, so we would say d dx, and then we would say the function. So then second derivative would be d, you see the 2 here, and then dx squared f of x. So please remember the square is not saying you need to square anything, it's just saying the second derivative. And then the third derivative would be like so. The fourth derivative be like this. And then the nth derivative will be like this. Another way you might see it is with a big D like this. dx y, so derivative of y with respect to x, and then like this for second derivative, third derivative, fourth derivative, and then nth derivative. So let's go ahead and look at one question. Find the first 4 derivatives of y. Okay, so first derivative, so use power rule, 3x squared minus 10x. Second derivative, So do the derivative of the first one. So 6x minus 10. Third derivative, it's going to be 6. And then the fourth derivative, 4, is 0. All right, let's look at a slightly different kind of application. So that was just kind of to show you how to write derivatives in higher orders.
So let's look at this question. The velocity of an automobile starting from rest is v of t equals 100t over 2t plus 15, where v is measured in feet per second. Find the acceleration at number 1, 5 seconds, and 2, 10 seconds. So this is kind of similar to the questions before, and you got to remember again that the derivative of position becomes velocity, and the derivative of velocity becomes acceleration. So this has to be a fact that you memorize. So in order to find acceleration when you are given velocity, you know you need to take derivative. Now they're asking you what is the acceleration at particular time meaning at that instant, and then we know that means we want instantaneous rate of change, the IROC. So that's why we do the derivative at a specific time. So this is a pretty easy problem. So it's just saying what is the acceleration at that time. So we know that acceleration is the same as the derivative of velocity, and we just want those accelerations. So for example, number 1 is just asking for a of 5, which is the derivative of v at 5. And then number 2 is just asking for a of 10. So just a little bit of a note. Please remember you got to write this. You cannot just have this because if you just say a of 5, you cannot assume that the reader knows that you took the derivative, or you know that the derivative of the derivative of velocity is acceleration. So make sure you do write somewhere that a of t is equal to v prime, telling the reader you understand that if you want to find acceleration, you have to take derivative. All right, so we need the derivative of v, and remember to do that first before you plug in the actual the time for the 5 seconds and 10 seconds. All right, so v, v prime. All right, that's another thing. Sometimes you start taking derivative and then you don't label anything. You don't label v prime, and you just start to have this expression. That's not okay. You got to label that as v prime. All right, so this is going to be a quotient rule. So low d high minus high d low all over low squared. I'm gonna try to clean up the numerator a little bit, but not too much, because I don't think there's anything that's really gonna simplify beyond just very little parts of it, but we'll see. Looks like the 200t is gonna cancel, so we have 1500 over 2t plus 15 squared. Okay, so for the most part, for denominator, please don't expand it. There's no need. We're just trying to figure out what the value is at 5 and 10, so we just need to plug it in. All right, so this is going to be 1500 over 2 times 5 plus 15 squared. And then so we use our calculator, and we get 2.4. All right, we do the same thing for a of 10, so 1500 divided by 2 times 10 plus 15 squared, and we get 1.224. Okay, make sure you round to 3 digits after the decimal. Now let's talk about units. So it tells us that velocity is measured in feet per second. So now if we're finding acceleration, we're taking the derivative. So when we take the derivative, we're basically saying, remember, slope is derivative, right? So it's change of y over change in x. So if you have velocity versus time, and we are saying velocity, hopefully this will make sense. Velocity is feet per second, and time is seconds. So then if we want to find acceleration, we said acceleration is going to be the derivative of v, which means the slope of v, right? So acceleration is the slope of v, so that's change of v over change in t, right? Because in this case, v is the y direction, and then t is the x direction. So remember, change in y and change in x, in this case, is going to be change in v over change in t. So then kind of like what I mentioned before, how do you figure out the units? Well, let's just put the units in. What is the unit for velocity? That is feet per second. And what is the unit for time? That is second. And so remember, this is not going to end up with feet. This is, remember, this is second over really 1, right? So then if you have a fraction divided by fraction, it's the fraction times the reciprocal. So this unit is feet per second squared. Okay, so this is all feet per second squared. Feet per second squared. One way I try to remember the unit without actually doing this whole calculation is if I know that I am finding a derivative, I would take the original unit and then I divide by that the per unit again. So in the original one was feet per second. I know second is the one I'm dividing by. So then I know if I want to take the derivative, then I will have to divide by that unit one more time. And same thing, if I had to go from acceleration to the next derivative, I know I have to divide by second again. So that's kind of how I kind of find a shortcut to find a unit if you don't want to do this whole unit calculation every single time. So this is, kind of a trick.